Hey, I'm Kirsch. In this video, I'm going to get very surgical. A lot of times there can be just one device in your design that will cause it to fail. But luckily, there is a way to test for this before you send your design out for production. And it's using the Parametric sweep simulation function in PSpice. In this video, I'm going to show you how I set that up, how to use it, and exactly how useful and powerful this feature is. All right, so I decided to choose a component that I feel like is critical in a design, and I ran a parametric sweep on it. Let me show you the settings. So to do a parametric sweep, or what is even a parametric sweep? It's something where you choose a component or parameter and decide to vary the values on that component. So I've decided to vary the value for my RS, or sensing resistor. So how I set that up was I got the param object. This is the param from the special.olb or special PSpice library. I put it in there, added this property for the RS, and made the property and the value visible. Okay, and this is by standard or default value. Once you do this, you can put parentheses or braces rather around the variable that you want to vary. Okay, once you have that set up, then you go into your PSpice simulation profile. So go to PSpice, edit simulation profile, and then we're going to add parametric sweep. I turned off Monte Carlo / worst case, and I add parametric sweep. Went with global parameter. Okay, global parameter, and that's going to be what? RS in those braces. And then I said I want my start value to be 20 milliohms for this resistor, and then up it to 50 milliohms with an increment of 5 milliohms. So we're looking at 25 milliohms, 20 milliohms, 30 milliohms, and so on and so forth. Okay, just to see how does this circuit behave with these different resistor values. Now, since I already set that up and I ran my simulation, check out the result. Boom, we have a lot of waveforms. What does this mean? Okay, we've ran our simulation at the different sensing resistor values, and take a look at this. If I click here, notice how this V out is collapsing. That's not good. This was a very frustrating problem when I was running these simulations, because I was trying to figure out, why is my V out collapsing? I tried so many different things like the capacitor, and come to find out it's the sensing resistor. So if I were to right click on here and then choose trace information, it reveals to me that my sensing resistor only being at 20 milliohms is a problem. Okay, but when I'm above 20, let's say when I'm above 25 milliohms, if we look at that trace information there, then I'm golden. So even though I had calculated that 23 milliohms, 20 milliohms or so would be fine, not the case. But because I can run this parametric sweep, this analysis, I can see that I definitely need to stay at minimum 25 milliohms and above for stable output voltage. One little resistor, okay? One little sensing resistor. You also have options for power consumption and whatnot, and analyzing the power on that. But see that this is powerful. This is the power of using parametric sweep. And how would you even know which components to do parametric sweep on? Well, that comes from your Monte Carlo analysis and your other analyses like worst case. And that wraps up this video. You now have all the tools necessary to finalize your PCB design before you even touch the PCB stack up, and long before your product ever reaches the market. And this is true regardless of the limits of what you can test physically in the lab. Now, while simulation isn't real life, the insights we gain clearly help us make way more reliable products. And that's all done in a single afternoon with me, saving you months of failed boards and frustrated customers. So thank you for watching, and I'll see you in the next one.